Hello and welcome to today's lesson. Today we're going to look at the ellipse. Now the ellipse is really just a circle that doesn't have a consistent radius. It's been stretched a little more in one direction than in the other direction. So you should find that if you approach this thing almost like it's a circle and then deal with the changes as you come to them, should make it pretty easy. So I'm going to dive right into an example and say, we want to graph this guy. So notice I've thrown in a few shifts here just to make it interesting. Got to keep you guys on your toes. Okay, so there is a nice equation that we're told to graph. Well, notice something that's very different from a circle. You don't have the same two numbers on the bottom. In other respects, it looks almost like a circle. I mean, you've got your x with a shift squared plus you've got a y with some kind of a shift squared equals 1. But the big difference is those numbers on the bottom are different. Well, let me just show you how easy it is to graph this thing when it's in standard form, which is what we really like. Okay. On the x-axis, we want to shift the thing over to positive 2. And my little dotted guideline. On the y-axis, we want to shift it over to, down to negative 1. And the guideline. So there's the center of my ellipse. Now the next thing is, on the x-axis, I want to go 3 to the right and 3 to the left. So 3 to the left and 3 to the right. On the y-axis, I only want to go up and down by 2. So from center up 2 and down 2. Well, now I just join the dots and guess what? There's my graph. It's a little tricky to draw these things. Sometimes you end up getting kind of an egg or something. So practice makes perfect. There it is, our first ellipse. Now, they're going to ask you for things. They being the people who test you. They're going to ask you for things like you're supposed to identify the major axis. Now, the major axis is the longest one. It's kind of like saying the longest diameter. So, if you look at it, an ellipse has different diameters. Well, the longest possible diameter is this one here. Okay? So it's going to go, well, we went 3 to the left and 3 to the right, so that makes it a total length of 6. The smallest or shortest diameter is called the minor axis. And this one from center we went up 2 and down 2, so it has a length of 4. The other thing that might be asked of you is, where are the vertices? Okay, well, the vertices are always on the major axis, and we're talking about these 2 points here. Okay, they're kind of the endpoints of your major axis. So we just identify them off our graph. This is ended up at negative 1, and we shifted down negative 1. And the other one is that we were here at 2, we went over 3 more, so this is at 5, and also a y value of negative 1. And there it is, your first ellipse. So easy, so fun. Let's carry on and just summarize what you've just seen. What you've seen here is standard form. And standard form looks like this. There may or may not be some kind of a shift, and we're going to put that over A being on the x direction, which is left and right. You're moving A to the right, A to the left. And the same idea over here. There may or may not be a shift. I just called it y minus k. And we'll just put b on the bottom for the distance that you go from center up and down. And equals 1. So that's the form we really like. Sometimes it's written like this. We don't often, people like to not have this included, so they separate it and write the a squared on the bottom. It really makes no difference. So either one of these, so I'll just say or, is called standard form. Now, the ones that get messy are the ones that aren't in standard form. Standard form makes graphing simple, easy, maybe even fun. But what if it's not in standard form? What are we going to do? Glad you asked. Let's do an example that illustrates that. So in this example, we've got 9x squared plus 4y squared minus 18x plus 16y plus 21 equals 0. Now, you might remember this is called general form. General form requires some rearranging, some completing the squares, maybe even some tiers. But we carry on. So, what am I going to do? Well, I've got 9x squared minus 18x. Well, the first thing you have to do, and sometimes it's a little bit slippery, whatever number is in front of x squared must be factored out. So I'm going to take that 9 out, whether I want to or not. That's just the way it is. So that will leave me with x squared. And I'm also going to group in with it this negative 18x. Well, remember, you factored out the 9. So what you now want to write in here is minus 2x. And leave a little space. Okay? Now we're going to do the same thing when we carry on with the y's. We have this positive 4 in front. So out it goes. And that will leave me with y squared. And I got this positive 16y, but remember you have the positive 4 sitting out front. So this will be plus 4y, leave a little space, and I always like to move the other extra number to the other side. So I've got minus 21 thrown to the right. Okay, now we're going to complete the squares. So what do? Well, we need half of this negative 2, which is negative 1, squared positive 1. Okay, well that's kind of nice. We've completed that. But what number did you actually bring in here when we completed this square? And it looks like a 1, but remember it's still affected by the 9 that's been factored out. So you actually brought in a positive 9. So what you have to do is compensate by putting a plus 9 on the right side. Let's go to the next one here and complete the square. Well, it's positive 4. Half of that is 2. Squared is 4. But the number you actually brought in was 16. So we're going to compensate by bringing in a 16 over on that side. So now what do we have? Well, when we factor this, it now looks like this. 9, and then we have here x minus 1 squared plus 4. And then here we have y plus 2 squared equals. Now, what do we have here? This is positive 25, take away 21. So that's 4. Okay. We're almost there. What we like to do now is get the whole thing equal to 1. So I'm going to take everything and divide by 4. Well, what does that do for us? Okay, well, first of all, those 4's cancel there. That's kind of nice. And that's going to turn into a 1 on the right. But the real thing I got to figure out to do is, what do I do with this mess here? There's a sneaky little trick. When you have a number sitting in front here that doesn't cancel nicely and is still sitting in front, we don't really want it sitting in front. So what we do is we bring it in with the bottom, with the denominator. So instead of leaving the 9 out in front here, I'm going to erase it through the magic of chalk and then put it down here. Now there are probably some of you watching this saying, you can't do that. I just did, but let me explain why it works. Imagine now if I said, hey, I don't like this, there's a fraction within a fraction. I could theoretically do this. I could multiply the top and bottom by 9, right? And then the 9's would cancel, and look what you have. You have 9 times this and the 4 on the bottom. So I think it is exactly allowed, and so I'm going to do it. So it's a sneaky little way of getting rid of numbers that are sitting up front. Now I've run out of room yet again. So I'm going to write on the top what my standard form equation looks like. Okay? Now, as you can see, I cooked up this example to work rather nicely in that both of these things have nice square roots. Okay? So I'm going to write it like this. I've got on the top x minus 1, and on the bottom I have 2/3. Okay? That being that, because I'm including it in the squaring process here. If you square 2/3, you'll have your 4/9. Now this one's kind of funny. There's no number on the bottom, but in fact there is the number 1. So I'm going to write it like this: y plus 2 over a 1 squared, and now it all equals 1 on the right side. So we'll just pause for a moment there and admire this lovely standard form before we go ahead and graph it. All right, we finished pausing. So now let's draw the picture. Okay, so let's get the shifting out of the way. We're going to shift 1 unit to the right. And we're going to shift the whole thing down 2 units. So that's where my center is. Now what I need to do is on the x-axis, I only want to go 2/3 to the right and 2/3 to the left. Well, that's kind of funny, but actually it's pretty easy to draw. It just means don't go a whole unit, just go 2/3. Approximately there. And let's just say that's a whole unit here, so 2/3 would be about there. And on the y-axis, I want to go up 1 and down 1. So up 1 and down 1. And there's my little ellipse. Little but elliptical. Very poetic. Okay, let's identify a few things like the major and minor axis. The major and minor axes. And we should probably list the vertices as well. Okay, the major axis is the long one. Well, in this case, that's the vertical. So that means we went from center up 1 and down 1, so the major axis is 2. The minor axis is the small one, and that means we've gone 2/3 this way and 2/3 that way. 2/3 and 2/3 makes a total length of 4/3. And identifying where are the vertices. They're these 2 points, always the ones on the major axis. So they've both been shifted 1 to the right. We've got our x's, and then we just got to figure, well, from center here, which was at an elevation of -2, we went up 1. So that means -1. And we went down 1. So that would be -3. And that's that example. Okay. I have one last example to do, and then I will stop talking about ellipses for now. In this last example, I'm going to give you a situation where we don't know the equation. I'm going to give you clues, and you're going to find the equation. So let's see what we got here. We'll tell you, first of all, that we have a center. And we're going to say it's at -2 and 1. And we're going to say that it passes through. Now, in order for this to work, I've got to give you a couple of points. 1 isn't good enough anymore. Worked okay for a circle because the radius was the same, but not for an ellipse. So I'm going to give you a couple points here, one of which looks like this, -5 and 1. And the other point is at -2 and 6. Okay, we're going to find the equation. Well, what you want to do is start off and say, well, in standard form, I have a situation that looks like this. X minus h. Now let's figure out what that shift is. If my center is at -2, well then this must be x plus 2. Mystery solved. Okay. And let's mosey on to the next one. For this guy, we want to shift the whole thing up to positive 1, so this must be y minus 1 equals 1. So the only thing we don't know is what is A and B. What are these lengths? What are these distances? Okay? And we're going to hope that maybe there's enough information built into this that we can just identify those. Because we have two different variables, two different unknowns, just plugging in the -5 and the 1 and plugging in the -2 and the 6 can often be more work than it's worth. What I'm going to do is have a quick little gander at the picture. So let's have a little look here. Our center is at -2, 1. So I'm going to put a dot there. I'm going to put a little C next to it, indicating that's the center. So that means that we shifted 2 to the left and up 1. Then we have these points here. Well, let's have a look at what these points are providing us. -5, 1. So I'm going to go, this is -1, 2, 3, 4, 5, and up 1. Well, what does that tell me? If that's a point on my ellipse, it just told me on the x direction how far we moved to the left. We went from a center at -2 and we moved over to -5. So we moved over 3. So I got that just by looking at the picture. That's not too bad. Okay. Now let's see if that other point might provide some information on the y direction. Well, I think it does. It says his other point is at -2 and up 6. So up, let's see, -2, 1, 2, 3, 4, 5, 6. So it's up there. So all I need is this distance. Well, we're already at 1, and then we moved up to 6. So that's a distance of 5. There it is. Okay, so drawing it out is often a very helpful way of analyzing something that may have been able to have been done through some algebra, but maybe this was just a much easier way to do it. I always like a picture. I find it very helpful. And with that, I am done talking ellipses. We'll catch you later.